The HTTP error codes in the 400 range are reserved for cases where the client does something that causes the server to be unable to complete the request. The most famous code of all is 404, but there's actually around 30 in total. I've decided that I will split this video into 3 separate parts. The first part will be 400 to 409, the second part from 410 to 419, and the remaining codes in part 3. The 400 bad request code is sent back from the server in cases where the client created a request that the server could not understand or didn't follow the HTTP specification. Browsers, of course, don't create invalid requests on their own, but if you're writing your own client accessing an HTTP server, it is certainly possible that you might misprogram the tool. To demonstrate, the easiest thing to show a bad request is to use my manual web client, and we'll request the HTTP, that's 3 T's, version 1.1. We will still include the host line, but many servers actually fail the same way if you leave out the host header. The 401 unauthorized code is used by the server to indicate that while the request was valid, the server has determined that the client did not have the authentication credentials required. We'll use the manual web client first for a quick demonstration. The secrets folder has a restriction that basic authentication is required to access this area. And since we did not send any credentials, the server is sending back an indication that we do not have access and that basic authentication is required. Showing this under Firefox is a bit more interesting. In this case, the 401 response code causes the browser to open a prompt asking for a username and password. Entering these will resend the request with an authentication line. The purpose of the 402 payment required has a pretty obvious use, but unfortunately the implementation is really not obvious. The current consensus is that this is still reserved for future use. We can demonstrate this here as a simple web application that returns a 402, but there's nothing in the specification that explains how you would actually go about dealing with the payment. The 403 forbidden response is an indication that the server has refused to process the request. At first this sounds pretty much like a 401, but unlike the 401, which could be requested again with the credentials, the 403 is essentially saying that you will not be getting any access to this item. Typically the failure is tied to insufficient permissions. Sometimes these errors appear as a result of misconfigured file permissions on the server, but web applications can use them to indicate that the current user does not have the permissions to obtain the resource requested. I had actually joked to myself about leaving the 404 completely out of this video, because of course, well, the 404 means something wasn't found. In all seriousness, this is the one that everybody understands. Browser asks for a page doesn't exist, and the server responds back a 404. The 405 code is a response from the server that will occur if the client attempts to use a method on a resource that has been configured to only accept some other methods. If we run a get on this API event resource, we get a 200 response. The same is true for post operation. However, if we attempt to use a put operation on the same URL, it comes back with a 405 method not allowed. In the headers, the web server has been kind and has listed the allowed operations of get and post, so there's at least a small hint about what the client might have done wrong. The 406 code indicates that the request was not acceptable. At first, this could be misinterpreted as some kind of a permissions problem or some kind of a syntax, but the code has more to do with content negotiation. When requesting a resource, the client can make several suggestions about what it would like. For example, maybe it wants a file in a certain language, maybe it wants a compressed file. Since we have more control in the request headers in Postman, we'll use this to do the request for a document resource for my server. The initial request comes back as plain text. If we go to the request headers and remove the default one provided by Postman and insert a request for an HTML version of the document, we'll see we get back a text HTML document instead. Finally, if we attempt a type that is not supported by the server, such as a JSON file, the server responds back with the 404 not accepted. The server itself, Apache in this case, produced the HTML that the browser could display so the user could pick something. The 407 proxy authentication required message obviously has something to do with both proxies and authentication. A proxy server is a web server whose job is to request pages on another client's behalf. This can be useful if you need to access a certain server while traveling, but can't reach the server directly. These can also be used to cache documents to make the entire browsing experience faster. Many proxy servers are configured to require authentication because generally you don't want a bunch of random people using your proxy. We can demo this by using Firefox and going to firefox.com, and the page loads completely normally. We will now enable a proxy server within Firefox, which is saying that all requests should now be requested through the proxy. When we attempt to reload the page, we can see that now we are getting a 407 response that's coming from the proxy server, and this is causing the browser to open a username password dialog box. The important thing here is to remember that the proxy is requesting the credentials, not firefox.com. A 408 request timeout means that the server received some of a request, but not enough to actually process it, and simply gave up waiting. A simple way to see this is to write a partial request using, say, Telnet. We'll connect to the server on port 80 and send in just the first line of the request, but we won't complete the request, in particular, the blank line. The server has received the first line and is basically just waiting for the blank line or for more data to process. However, eventually the server just wants to terminate because it appears to be a dead connection. The 409 conflict response code is a code that's used to indicate that the request cannot be processed due to some other condition. In the case of WebDAV, 409 messages are used to indicate conflicts in the file system. We have here a WebDAV repository with a couple of documents and no folders. The put operation shown here will create a new resource on the server. In this case, a plain text file containing the word hello. However, you'll see that the resource is referring to a folder called sub, which of course doesn't exist. The response is a 409 conflict. Web applications are free to use this code for any purpose, such as modifying a resource which is currently being modified by some other task.